So as part of our regular biochemistry practicals, so today I want to discuss about the preparation of standard buffer solutions and measurement of their pHs. So now I will discuss about the preparation of the standard buffer solutions. So first, so what is a buffer? A buffer is a solution which maintains its pH when we added the acid or base to a solution. So for example, you take this as a solution. So it has some pH. Normally, if we add the acid or base, depending on the content of the acid or base, the pH will change. If we add acid solution, automatically the pH will lower and it will become acidic. If we add a base to the solution, so slowly the pH, the basic nature will increase. Automatically, we can observe the increasing of the pH, and so we can observe the increasing of pH. So, but in the case of buffer, it is solution. What it will do, maintains the pH constantly. If we take example, if we take this as a buffer, if we add acid or base, so almost is try to manage the pH in the same constant, or a slight change we will observe. So the reason is the ions will dissociate, either the hydrogen ions or the OH hydroxyl ions or some other, they will dissociate, and according to that they will respond and they will stabilize the pH. Okay, so because of that reason, the buffer preparation is a very important. So one more time I will repeat. So a buffer is a solution which maintains its pH fairly constant even upon the addition of small amount of acid or base. So normally in the practical purpose, so in order to evaluate the dissociation of a drug, or in order to evaluate the dissolution of a drug, or in the biopharmaceutics, in order to evaluate the kinetics of a drug, so generally we will prepare the buffer in vitro conditions, and to that we will add the drug, and we will assess the drug kinetics, the drug dissociation, dissolution, each and everything. So for that also we need a buffer. And in the normal body, so you already know homeostasis. So a normal constant environment will be maintained in the body. So how this normal constant environment was maintained in the body? So one is because of the production of the buffers by the body and maintaining of the pH in the normal situations. And in the physiology, the respiratory system, we already studied about the formation of the carbonic acid, formation of the phosphoric acid. So there what happens? This high water, it combines with the carbon dioxide in the presence of enzyme carbonic anhydrase, it converts into carbonic acid H2CO3. So depending on the pH, the fluctuation will vary. So for example, the body suddenly the pH is raised, the alkaline environment is produced. So in order to maintain the pH, immediately this carbonic acid will undergo dissociation to H plus and HCO3 minus, and this H plus automatically will neutralize the alkaline pH and will bring back the pH to the normal. In that way it will happen. So the same thing will happen in the opposite situation also. So for example, suddenly because of more ketone acids production, so like acetate, beta hydroxy pyruvate, like that, or those ketone bodies or ketone acids like pyruvate. So what they will do, they will decrease the pH of the body. So in that case, it is a very difficult for the enzymes to do their catalytic activity and do their functions. So generally we need a favorable conditions to get the maximum catalytic activity from the enzyme. So immediately the body will respond, will increase the pH. It means it will try to neutralize the acidic to neutral pH. So how it was happen means the same. Carbonic acid dissociate to H plus and HCO3 minus. This HCO3 minus, it will attach with the H plus ions, and it involves the formation of the new carbonic acid H2CO3. So in that way, the body, the system will respond. So here, the very important one is the buffer. So in order to know that one, you need to know the buffer. So that is so. What is the importance of the buffer? So in vivo importance, in vitro importance. So first I will go with the in vitro importance. So in the case of in vitro, so in order to evaluate the bioavailability and pharmacokinetics, pharmacodynamics of the drug, so we will produce some artificial conditions. So in the artificial conditions, we evaluate the activity of the drug. So there, say for example, so we want to evaluate the activity of a drug in the acidic environment, particularly in the stomach pH. So what we'll do, we'll prepare a strong buffer or acidic buffer. So that medium we will use to evaluate the activity of the drug. In that way, we will evaluate so how the drug will respond to that particular pH. So similarly, we will prepare some other pHs. So 5 pH, 6 pH, 7. So we will evaluate at which pH the drug showing maximum activity, at which pH the drug was has a good absorption and distribution. So all that. So that is the in vitro importance of the buffers. In vivo. So in vivo, say for example, we discussed already. So the carbonic acid formation and this carbonic acid dissociate to H plus and HCO3 minus, or sometimes it will dissociate to water and carbon dioxide. And phosphoric acid is an H2PO4, it dissociates to H plus and HPO4 minus. So all these will act as a buffers. So they will try to resist the pH changes and they will try to bring back the pH change in the body to the normal. So then only will have the maximum metabolic activities. So otherwise, the overall metabolic activities will be disturbed, and so there may be chance for the getting of the metabolic disorders also. So that is the in vivo importance of the buffers. So next, I will go to the types of buffers. So different types of buffers are there. Okay. First one is the acid buffer. The second one is the alkaline borate buffer. The third one is the phosphate buffer. So in the phosphate buffer, by using two types of substrates, we will prepare the phosphate buffer. One by using potassium dihydrogen phosphate and sodium hydroxide. So we call it as a KH2PO4, the potassium dihydrogen phosphate, and by adding that to the sodium hydroxide and water, we get the phosphate buffer. That is the one way of phosphate buffer preparation. The another way of phosphate buffer preparation is the mixing of the disodium hydrogen phosphate, Na2HPO4 and citric acid. So also we will get the phosphate buffer. It's alkaline borate buffer. It's alkaline borate buffer. How we are preparing is by mixing the boric acid with the potassium chloride and these two with the sodium hydroxide and water, we will get the alkaline borate buffer. Like acetate buffer. So acetate buffer, generally the pH is 2.4. Generally, if you want to assess the activity of a drug in a strong acidic environment, in that case, we will go with the acetate buffer. So this acetate buffer we are preparing with the help of substrate sodium acetate. So these are the types of buffers that we are preparing in order to maintain the pH. So clinically, the very important one is the phosphate buffer. Generally, in the biopharmaceutical medical experiments or in the in vitro studies, we'll go with the phosphate buffers only. So these phosphate buffers we can prepare from a range of 2 pH to 10 pH. In the case of this alkaline borate buffer, generally in order to produce the alkaline pH, we will use these buffers. Generally, this alkaline borate buffer, so the pH is ranging from 8 to 10. Next, this acetate buffer generally is used to produce the pH 2.4. And normally, so two important pHs are very important. One is the 6.8 pH, the other one is the 7.4 pH. Generally, the enzymes they show their maximum activity at the neutral pH, so that is 6.8. So normally, most of the biochemical experiments like enzymatic hydrolysis of starch, so study on the substrate concentration of enzymes and effect of temperature on the enzyme. So for all these experiments, generally we will go with this phosphate 6.8 buffer. The 6.8 buffer is very important to produce the favorable conditions for the enzyme maximum enzyme activity. One more one is there in the phosphate buffer, that is called as the saline phosphate buffer, that is the pH is 7.4. Generally, that is we are using to neutralize the acidic environment. For example, the person have any sudden problem of acidosis like that, immediately we'll go with the administration of that saline phosphate buffer. Automatically will neutralize the pH and it will make the metabolic activity to the normal. So that is about the types of buffers. Next, preparation of the buffers. In the preparation of the buffers, so today I want to explain about the preparation of the alkaline borate buffer and phosphate buffer. So here, in the buffer preparation, first you need to prepare the stock solutions of those strong acids. Salts of the strong acids are strong bases. So one, say for example, if you are going to prepare the alkaline borate buffer, first we have to prepare the so 0.2 normal sodium hydroxide solution. So how we are preparing this 0.2 normal sodium hydroxide solution means, if you want to prepare for 1 liter, so normally the molecular weight of the sodium hydroxide is 40 grams. So for 1 normal pH preparation, generally for 1 normal NaOH preparation, we will take generally 40 grams of sodium hydroxide. We will dissolve in 1000 ml of the water. In the case of 0.2 normal means, so what we will do, we will take 8 grams of sodium hydroxide, we will dissolve in 1000 ml of the water. So automatically we will get the 0.2 normal sodium hydroxide solution. So the 0.2 normal sodium hydroxide solution is very important. Generally that we are using to make the buffers. The second is the preparation of the 0.2 molar boric acid and potassium chloride solution. So for the preparation of alkaline borate buffer, first we have to prepare the 0.2 molar boric acid and potassium chloride solution. So generally for the preparation we need to take 12.3 grams of boric acid and 14.7 grams of potassium chloride, and we will dissolve that in the 1000 ml of the water. So automatically we will get 0.2 molar boric acid and potassium chloride solution. So one more I will repeating. So for the preparation of 0.2 molar boric acid and potassium chloride solution for 1000 ml, so we have to take 12.3 grams of boric acid and 14.7 grams of potassium chloride. So both these we have to dissolve in the 1000 ml of the water. Automatically we will get 0.2 molar boric acid and potassium chloride solution. The step 3 is the addition of step 1 to step 2. And make up to final volume with the distilled water. So I will take one example. So first my task, I want to prepare the alkaline borate buffer and the pH is 8.0. So I want to prepare 8 pH alkaline borate buffer. So how we have to prepare is, so for example, if you want to prepare for 250 ml, so first we have to take 50 ml of the 0.2 molar boric acid potassium chloride solution. To this 50 ml, we have to add 4 ml of the sodium hydroxide solution and make up the final volume of the 250 ml with the distilled water. In that way, we will prepare the 250 ml 8 pH alkaline borate buffer. In the lab, it's very difficult to prepare 250 ml. So for that, generally we will prepare for 10 ml or 20 ml like that. So how we have to prepare the 10 ml of the 8 pH alkaline borate buffer. So here first we have to take 2 ml of the 0.2 molar boric acid potassium chloride solution. To this, add 0.8 ml of 0.2 normal sodium hydroxide solution and make up the volume up to 10 ml with the distilled water. In that way, we will prepare. So, because of that reason only, in this table also I mentioned only pH and sodium hydroxide. So, in buffer preparations, the volume of these natural substrate is a standard one. Say for example, if you are preparing for 10 ml, generally we will add 2 ml. If you are preparing for 250 ml, we will add 50 ml. Okay. So depending on the pH, the sodium hydroxide quantity will vary, and automatically we will prepare the pHs. So subsequently, if you want to prepare 8.2 pH with the alkene borate buffer as alkene bore buffer, so the thing is, so mix 2 ml of 0.2 molar boric acid potassium chloride solution with the 1.2 ml of sodium hydroxide solution and make up the final volume up to 10 ml with the distilled water. So similarly, 8.4. So 2 ml of 0.2 molar boric acid potassium chloride solution, 1.7 ml of 0.2 normal sodium hydroxide solution and make up the final volume up to 10 with the distilled water. Similarly, 8.6. So the 2 ml is a fixed one. So for that we will take 2.5 ml of the sodium hydroxide solution. In the case of 8.8 pH, so we will go with the 3.2 ml of the sodium hydroxide solution. As the volume increases, the pH will also increase. Next 9 pH. So what we will do? 4.2 ml of the sodium hydroxide solution. Next 9.4 pH. 6.4 ml of the sodium hydroxide solution. Next 9.6. 7.4 ml of the sodium hydroxide solution. 9.8. For pH 9.8, we will take 8.1 ml of the sodium hydroxide solution. If you want to prepare 10 pH, pH 10, so we will take 8.7 ml of the 0.2 normal sodium hydroxide solution. In that way, in the proportion, we will mix the 0.2 molar boric acid potassium chloride solution with the 0.2 normal sodium hydroxide solution. We will make up the final volume up to 10 ml with the water. So the very important step in this is if you want to measure the pH of these buffers, okay. So in order to measure, generally we will add the indicator, that is universal indicator. The universal indicator will react with all the solutions. Depending on the pH, will produce the color. So based on the color, we will assess the pH of the solution. That way, actually, we will measure the pHs. Okay, but I will discuss in the next session. Next, another example I will take, that is the phosphate buffer. So if you want to prepare the phosphate buffer solution with the potassium dihydrogen phosphate and sodium hydroxide, so here all the same thing. First we have to prepare the 0.2 normal sodium hydroxide solution. The next thing is that we have to prepare the 0.2 molar potassium dihydrogen phosphate solution. So how we have to prepare? So very accurately. So 17.5 grams of potassium dihydrogen phosphate and dissolve it in 1000 ml of the distilled water. Automatically we will get 0.2 molar potassium dihydrogen phosphate solution. So next, depend on the sodium hydroxide proportions, we add that to the potassium dihydrogen phosphate solution and make up the final volume of 10 ml with the distilled water. Here also I will take. So as we know, the 6.8 pH is in the laboratory purpose or in the in vitro purpose, it is very important. So how we will prepare that 6.8 phosphate buffer? So the step one is we will take 2 ml of the 0.2 molar potassium dihydrogen phosphate solution. To that we will add 4.5 ml of 0.2 normal sodium hydroxide solution and we will make up the final volume up to 1000 with the distilled water. Okay. So like that, 7.2, 7.4. So these are very important in the laboratory purpose. Okay. So in the case of 7.4 pH, so we will take 2 ml of the 0.2 molar potassium dihydrogen phosphate solution, 7.8 ml of the 0.2 normal sodium hydroxide solution, and we will make up the final volume up to 10 ml with the distilled water. So like that, 8 pH, like that we will prepare. 8 pH means we will take 9.2 ml of the sodium hydroxide solution. So now I will show you how to prepare. So 3 or 4 phosphate buffers. So I am taking the examples of phosphate buffer pH 6 and phosphate buffer 6.8, phosphate buffer 7 and phosphate buffer 7.4. So I will show. So first preparation of the 6 buffer. Generally for all preparations, first we have to take 2 ml of the 0.2 molar potassium dihydrogen phosphate. So now you transfer 2 ml of potassium dihydrogen phosphate into the test tubes. So transfer 2 ml of 0.2 molar potassium dihydrogen phosphate solution into the test tubes. Now add the specified quantities of the sodium hydroxide. Say for example, for the preparation of 6 pH, we have to add 1.1 ml of the 0.2 molar sodium hydroxide solution. So for the preparation of 6.8 pH, add 4.5 ml of sodium hydroxide solution. Make up the volume up to 10 ml with the distilled water. So after making volume of 10 ml distilled water, add a drop of universal indicator. So this universal indicator generally will produce the color. So this is the preparation of the standard buffer. In order to check the buffer, generally we'll add a drop of universal indicator. So mix gently. Automatically that will produce the color. Now this is the color of the that pH 6. pH 6 generally is neutral. Generally it will be produce the blue color. If it is alkaline, slowly it will produce the green color. So I will show one more example. So I am making 6.8 pH. So make up the volume up to 10 ml in the distilled water. Generally, in the prescribed manner, so generally for the preparation of 10 ml, we have to take 3 ml of the 0.2 molar potassium dihydrogen phosphate. To that, add the specified volume of the sodium hydroxide and make up the final volume up to 10 ml with the distilled water. So already we prepared the pH 6.0, 6.8. So now regarding the preparation of pH 7.0, 7.4. So take 2 ml of the 0.2 molar potassium dihydrogen phosphate and add 5.8 ml of 0.2 normal sodium hydroxide to make pH 7. If you want to make pH 7.4, add 7.8 ml of the so 0.2 normal sodium hydroxide solution. And so after adding the sodium hydroxide solution, so make up the volume up to 10 ml with the distilled water. So already for the 7.4 pH, we added 7.8 ml and previously 2 ml. So just we have to add 0.2 ml, very minute quantity. In the case of pH 7, already we added 5.8 ml of the sodium hydroxide and 2 ml of 0.2 molar potassium dihydrogen phosphate, 7.8 ml, remaining 2.2 add the distilled water. So now to this mixture add universal indicator. Mix gently, automatically it will produce the uniform color. Otherwise, you transfer to other test tube also or mix with the glass rod. So these are our preparation. The first one is the pH 6.0. The second one is the pH 6.8. third one is the pH 7.0, and the fourth one is the pH 7.4. As almost it is in the almost similar range, general will get a almost same color, but the intensity is varying. So you can observe the intensity variation in the intensity also. So some is slowly the color is changing. Here you can observe the bluish green color. Slowly it darken to violet color. Okay, slowly it will become green like that. So as the pH increases and it moves to the alkaline. So the present range is almost to the neutral. So this one is a very mild acid. Okay. So in this way, you will produce the color. Okay. So this is about the preparation of the standard buffer solutions. Similarly, we will prepare the alkene buffer, chloride buffer by adding the 2 ml of 0.2 molar boric acid solution and potassium chloride solution to the specified quantity of 0.2 normal sodium hydroxide solution and make up the volume of 10 ml with the distilled water. In that way, we do the buffer preparations. So regarding the measurement of the buffer, so in the tomorrow's class I will discuss